We have all experienced this and struggled to prevent our powder from clumping together during storage. Be it sugar, cane sugar, milk powder, infant milk powder, or any other powder, it is susceptible to clumping. In today's video, we look at the science behind clump formation. Lactose, we have seen, can undergo crystallization in several food products, leading to loss of stability of the system. This is true especially in systems like ice cream and milk powder. We do not want our lactose to crystallize as it can cause sandiness in case of ice creams and clumping in milk powder. So how do we control these products to extend the shelf life at an industrial level? Definitely you don't want to offer sandy ice cream to your consumers or clumped milk powder to your consumers. So how can we ensure that this does not happen during storage and distribution? This can be done by studying something called as glass transition points of food systems of interest. Glass transition is a concept that has been borrowed from polymer science, where we consider our biomolecules present in food, like proteins and carbohydrates, to behave like polymers, particularly at reduced temperatures. So if we consider lactose, it can exist either in crystalline form or amorphous form. When we talk about equilibrium conditions, lactose exists in crystalline form due to arrangement of molecules in an organized manner within the crystal lattice. Under non-equilibrium conditions, it is known to exist in amorphous form due to random arrangement of molecules. Now, when we go on reducing the temperature of a food product below a certain temperature, called as the glass transition temperature, represented here by Tg, okay, lactose exists in glassy state. Why? Because of increased concentration of lactose in the system. And this increased concentration of lactose is because of ice crystallizing out from the system at lower temperatures. Now, the system has increased lactose concentration, meaning the viscosity of system is going to be higher. Because the viscosity of the system is higher, biomolecules, they cannot move around freely. As a result, they collide with one another and they entangle, which restricts the movement of other molecules present in your food. In other words, this provides stability to your system. Glassy state can be attained due to plasticizing effect of water. What I mean by that is, if you look at this diagram here, under non-equilibrium conditions, lactose exists as an amorphous compound. So you have solution from which you remove water, you get rubbery state. On further removal of water, you get glassy state. Similarly, to glassy compound, when you add water, you get rubbery state. On further addition, you get the solution state. So this is the cycle that food or certain compounds undergo during storage and distribution. Now, glass transition, it is a second order phase transition which can be studied using a state diagram, because in state diagram you're going to accommodate both equilibrium conditions as well as non-equilibrium conditions. Now, when we talk about crystallization of lactose, what happens is, when lactose is present above the glass transition temperature is when crystallization occurs in your food products, and when it is present below glass transition temperature, it exists in amorphous form. So, glass transition is a concept that explains how non-aqueous fraction like lactose provides stability to our foods like milk powder and ice cream. If we can control this glassy state during processing and storage, then we can prevent undue crystallization of lactose in food products like ice cream. We can also prevent milk powder from clumping, meaning the product will have extended shelf life. Now, some of the features of glassy state, viscosity of glass is high, then restricted molecular mobility in glassy phase, and water acts as a plasticizer. This phenomena is widely used industrially in freeze drying, extrusion, spray drying to formulate a product that is stable during storage and distribution. Thank you for staying with me through the video. In case you have any queries, please feel free to put them in the comment section and I'll get back at the earliest.